morning. Today we are going to discuss on rubber products made from rubbers. I have mentioned in previous lectures that the names of different polymers showing elastomeric characteristics, rubbery characteristics, viscoelastic characteristics. Rubbers are flexible, soft, and it has got ample free volume which can accommodate large number of additives including fillers, in which fillers quantity is the highest and which is very high, means it can go up to 800 to 1000 parts in 100 part of rubber. You know what are the rubbers, basic names of rubber molecules, say natural rubber which is cis polyisoprene, synthetic rubbers styrene butadiene copolymer, polybutadiene rubber, polychloroprene rubber, ethylene propylene rubber, ethylene propylene diene rubber, butyl rubber which is a copolymer of isobutylene with a small quantity of isoprene monomer, purposefully introduced as a co-monomer to develop a cross-linking or vulcanization site or curing site. Then other rubbers, say acrylic rubbers, fluorinated rubbers or fluororubbers, fluoroelastomers, silicone rubber, and other polar rubbers like thiocol rubber which is polysulfide rubber, hypalon rubber, chlorosulfonated polyethylene. So, this way we can tell the names of many rubber polymers which shows elastomeric characteristics, and these polymers are blended with large number of additives, and the total number of additives can go as high as 30 in numbers. 30 different additives are normally incorporated, and there are few products where the numbers may be less, and these additives are known as the functional additives. That means, they have certain functions or roles to play during the fabrication processing of the rubber product as well as during the service of the rubber product when we use. Okay. Now, this slide shows the components, the major components present in a rubber product. Base polymer, this base polymer may be natural rubber, styrene butadiene rubber, polyisoprene rubber, butyl rubber, okay, polybutadiene rubber, chloroprene rubber, the names I have mentioned already. And filler system means we have to incorporate fillers which increases the volume of the product, rubber product, as well as sometimes there are certain fillers which imparts certain improvements in properties to they develop some broad spectrum of properties in the rubber products. Then processing system, this processing system, processing aid system, this is used in order to incorporate and disperse the additives which are going to include in rubber product, and that means it decreases the viscosity, increases the fluidity, and helps in incorporation and dispersion of these additives. Stabilizer system, it stabilizes the polymer, the rubber from the degradation present in the environment. I mean, the agencies like oxygen, ozone, heat, electromagnetic radiation like ultraviolet radiation, these actually degrade the polymers because these polymers are hydrocarbon in nature, and those are broken down, molecular weight is reduced, sometimes cross linking occurs, and it affects the final properties of the polymer. So, in order to protect from such degradations, the stabilizers are used, and which actually stabilize those degradation, they do not allow the polymer to be degraded. And then is the curing system. Curing, actually these rubber products, majority of the rubber products except thermoplastic elastomer, these are all vulcanizable or vulcanized products or cross linked products. That means, these are at the final form of the product, these are thermoset type. So, they are in the final form, these products are insoluble in solvents as well as infusible by heat. So, they are stable. So, for that purpose some curing agent or cross linking agent or vulcanizing agent, vulcanizing agent and these are used with the rubber product, and they help in cross linking the rubber molecules in order to convert it to thermoset structure from thermoplastic. Okay. I will discuss the details of these systems. Then miscellaneous additives, I mean say for development of anti-static property, in order not to your what is that called, development of static charge, accumulation of static charge on the product that causes attraction of dust and other things. So, this is not good for any product. So, if there is some anti-static agent mixed with the product, then that will not help, that will not actually allow this dust particle to be attracted to the products. And not only that, some fire retarding agents or flame retarding agents are needed to increase the flame resistance properties or fire resistance properties of the product. And sometimes abrasive powders, in order to get some abrading action, say abrading wheel that is used for abrading of some other surfaces. For that purpose sometimes say hard particles of hard materials say carborundum powder. So, these are incorporated in the product as miscellaneous additives. Along with this, there may be some tackifying agents, there may be some softeners. So, all these come in this miscellaneous category. Now, let us look into what is there in the curing system. Now, this in the curing system, cross linking or vulcanizing agents are there, means for the rubbers there are cross linking agents like sulfur, selenium and tellurium in the group of the periodic table. You see they belong to the same group, sulfur, selenium, tellurium. When they are mixed with rubber, they react chemically with the rubber molecules to link to the two molecules side by side, so that intermolecular linkage is developed through sulfur atom, that means through monosulfide to disulfide to polysulfide linkages. It cross links or forms a 3-dimensional network structure. So, that is actually the effect of cross linking agent. And in order to promote the reaction, in order to help the reaction between sulfur and rubber, some accelerator is used, which accelerates the reaction speed between sulfur and polymer. For that purpose accelerator is used. Accelerators are compounds of organic compounds. These are mostly amine derivatives. Accelerators are amine derivatives. So, these accelerators for cross linking are used in the rubber product for decreasing the vulcanization time. For example, in a normal vulcanization by sulfur only without using any accelerator, it takes about say more than 8 hours time, which is not economically viable or industrially feasible. Now, by using these accelerators and accelerator activators, all these things, these ingredients, it has been found that the vulcanization time has been reduced from 8 hours to 5 minutes or even 2 minutes. You see the effect or influence or the role of accelerators, how it is important and how it is essential in rubber products, you can understand from this phenomena. Then accelerator modifiers, you see this is again another category of this curing, another member of the curing system. Accelerator modifier means, now when we are incorporating this sulfur cross linking agent and accelerators, so these decompose at the vulcanization temperature, or when the temperature of the rubber compound increases, then these compounds may decrease as degrade, decompose and form free radicals, and those free radicals actually takes part in forming cross linking bonds. Now, during processing and fabrication, the rubber compound has to pass through these machineries at elevated temperature, say it may be sometimes the temperature goes as high as 80 to 90 degree or even 100 degree Celsius temperature. Now, at that temperature there may be the decomposition of a part of the your cross-linking agent as well as the accelerators, and there during processing and fabrication or before fabrication of the final finishing or shaping of the item, it may start vulcanization and cross linking. Now, if it starts, then what will happen? It will not flow properly and it will not fill the cavity of the mold. So, it will affect the shape and dimension of the properties. So, that your product. So, this is not good for such products. So, we have to control such type of adverse effects. For controlling that, we have to use some modifier. These modifiers may be of two kinds. One is retarder. Mostly modifiers are retarder molecule. That means, that retards the vulcanization, or premature vulcanization or premature cross linking before final shaping. Retarder molecules are used, say cyclohexyl N-cyclohexyl thiothalimide, N-cyclohexyl thiothalimide. This is a compound which is used for the retardation of vulcanization or retarding the vulcanization reaction, or it is actually a trade name is Santogard P6 PVI. You can say PVI or P6. PVI in other way you can say pre vulcanization inhibitor. PVI, you can say PVI pre vulcanization inhibitor, or you can say P6. Okay, this is the trade name of this compound, N-cyclohexyl thiothalimide. I will probably there are certain other examples in subsequent slides. I will show you. So, this is about curing system. Then stabilizer system, one is antioxidant and the other is antioxidants. Normally, these two classes of stabilizers are used in rubber products. Then let us look into the composition of rubber product. So, general class in these compositions are base polymer. I have already mentioned the names here, few names are shown here in this slide. Then fillers are carbon black, clays, whiting, silica fillers, etc. Then processing agents that increases the fluidity, reduces the viscosity, okay, and helps in processing, means incorporation and dispersion of the additives, particulate additives in rubber product. Okay. So, that helps in processing, say one kind of lubricating effect. It lubricates these particles, so that it can enter into that rubber molecules, rubber matrix. So, it helps in dispersion. Okay. Then comes curatives. Curatives are cross linking agents. I have already described the organic accelerators, organic and inorganic activators, promoters and retarders. Okay. There are also again promoters, means which promotes again this vulcanization, that means further in your increasing of the vulcanization rate, sometimes promoters are used along with accelerators and accelerator activators. Okay. Then anti-aging compounds, organic compounds as antioxidants and antioxidants, miscellaneous additives, coloring agents, abrasives, antistatic compounds, deodorants, all these things. Okay. Then now we have some idea what are the components or ingredients, general ingredients used in rubber product. Okay. Now we have to make a compound. You know, you have some concept of compound, means compound forms by linking of atoms of elements to form a new product, that is a compound, chemical compound. Now, it is not exact, it is also a chemical compound, but mixture of chemical compounds is rubber compound. The rubber compound means you are compounding together additives with the polymer rubber. So, the process of incorporation and dispersion and forming a semi homogeneous or near to homogeneous blend of these rubbers with the additives is known as a compounding, and the process is known as compounding. And major factors in compounding to be kept in mind before selection of ingredients to formulate a rubber product are price of the ingredients, processing characteristics of the rubber compound, and properties of the final rubber compound and the vulcanized product. Keeping in mind all these things, one can go for selection of ingredients, their appropriate dose, and then compounding requires serious and careful consideration by the rubber compounder, the person who actually deals with these things, who makes a formulation, who prepares this rubber compound for making a rubber product is known as compounder, rubber compounder. There are positions in rubber industries as rubber compounder. Okay. They work in the flows, the instruments, these machineries. Then let us look into rubber. This is natural rubber. You will see some properties of natural rubber. You will see some properties of synthetic rubbers little bit for your understanding. So, C14 polyisoprene is natural rubber. You know its structure. Properties of natural rubber is molecular weight. It is given here two different kinds of molecular weights, weight average molecular weight and number average molecular weight. So, this number average molecular weight is really wrong here. It will be less than 10 to the power 6. Okay. It is wrong, this value is wrong, it will be 10 to the power 5 or less than 10 to the power 5, 10 to the power 4 to 10 to the power 5 of this order. And molecular distribution is broad and high tag and green strength is required. I have already described before you what is the meaning of tackiness and stickiness, and what is the meaning of green strength of the rubber product. That means, green strength means after making a rubber compound, when we give a green shape prior to curing, the shaped item is known as the strength of the item prior to curing is known as green strength. Now, that is under green condition, it is not fully formed or fully cured. Then high tag and green strength and gum strength and good processing characteristics is available with natural rubber, and it is a crystallizing rubber, means if you stretch it, it is amorphous. If you stretch it, it develops crystallization, that means crystallites are formed. So, it increases the tensile strength, that is called stress induced crystallization, or you can say strain induced crystallization, stress induced crystallization or strain induced crystallization. The polymers which provides such type of performance or behavior is known as crystallizing polymer. Okay. Then vulcanized properties of natural rubber, tensile strength is, you see there some properties, range is given 17 to 24, it varies from compound to compound, varies from rubber to rubber, it is not fixed, it may be 15 to 28, 30, even here it is shown here 17 to 24, this is not rigid, it is variable, okay, depending on the nature of the polymer, depending on the nature and the number of additives and the quantity of additives used in there. Tensile strength of field rubber, field vulcanized is around 24 to 32. Okay. Then abrasion and wear. Say you think of a rubber tire, when it rolls on the road surface, the surface is rough. So, the outside surface of the wheel, which is called tread portion, gets worn out due to wear and tear, due to friction with the road surface. So, that wear resistance must be there, and there must be grip, road gripping, otherwise there will be skidding of the wheel. After sudden pressing of the brake, it should stop immediately. In advanced car, you find that even a car is running at say speed of say 140 to 150 kilometers per hour, that can be stopped within a very short distance. Today that kind of advanced car has been developed in the world, and I have the opportunity to see also that kind of car and to travel with that car also. It is so nice. Now, that kind of properties actually is available from this rubber. It has a beautiful grip with the road, so that it does not skid, it should not incur any accident, all these things, and it gives you very good gripping, road grip and skid resistance, wear resistance, all these properties. And for improved skid resistance. Sometimes oil extended natural rubber is used with this thing, and actually there is a science underlying this thing. In order to explain that thing, it needs more time. If you really want to know that science, you can discuss with me outside this class, I will help you. Okay. Dynamic properties means you think of again rubber tire, it is under dynamic stress. That means, while the wheel or the wheel is rotating, it is the contact between the rod and the wheel is under always dynamic stress. Stress your load, applied load, then after application it is released. So, continuously it is application and release, application and release. So, this kind of cyclic load is there. So, this is called dynamic stressing, and that is actually evaluated in the laboratory in simulated condition by flexing machine or fatigue to failure machine. That machine is there in our department, that machine is also there. If you are interested, you can see there. So, how it fails means it fails after initiation of a crack followed by crack propagation. Okay. Now, these rubbers are having properties like some rubbers are having resistance to crack initiation, but once a crack is initiated, crack propagates faster. There are some polymers where it does not resist crack initiation. Crack may be initiated, but crack propagation rate is slower. So, these properties are available with, say for example, natural rubber and SBR, they are having just opposite properties, these two. So, this way it is the duty of the compounder to select a suitable rubber in his formulation while he is making a tire. That means, he has to keep in mind for which area of the world, which part of the road this wheel has to be performed over there. So, keeping that aspect in mind, he will select a suitable rubber. Compression set and creep. You know what is creep? It is a flow properties with time under constant load. Creep is a property of deformation with time at constant stress. Creep is a property of deformation with time, elongation with time at constant stress and at a fixed temperature. Again, if the temperature is increased, the creep property will decrease. That means, it will deform more in less time. Okay. And relaxation, it is again a time dependent phenomena. It is the decrease of stress with time at constant strain, due to loosening of the molecules, due to relaxation of the molecules. Again, here is science, beautiful science. If you want to know, you can correlate, knowing that science, you can correlate these creep properties, relaxation properties. Aging, poor but improved antioxidants and antioxidants can prevent such aging characteristics. Synthetic rubbers, there are various polymers available as synthetic rubbers. These are homopolymers. Say polybutadiene is a homopolymer, styrene butadiene rubber is a copolymer, ethylene propylene rubber is a copolymer. Okay. So, there are homopolymers and copolymers which are used as rubber, and they are made by polyadditions of or polycondensation reactions of different chemical compounds for making a synthetic rubber. Why synthetic rubber? Why do you go for synthetic rubber? Now, the main reason is, if there is shortfall of natural rubber, if it is not available in a country, in one country, then they can synthesize rubbers. They can use synthetic rubbers if they do not have to, they do not have to depend on natural rubber, but if you have plenty of natural rubber, then you may not have to depend on synthetic rubbers, you can use synthetic natural rubber only. To meet the demands for some special properties where natural rubber fails, you see, to meet the demands for some special properties other than availability, if you have a special demands where natural rubber fails, there you can use synthetic rubber for some special purpose applications. For example, processability, oil and solvent resistance, low temperature flexibility, heat resistance properties, better dynamic properties, abrasion resistance, environmental stability. For example, say for a petroleum hose in the petrol filling stations, in the fuel filling stations, where the fuel diesel or petrol is pumped from the reservoir to the car. A pipe is used, that pipe is made of rubber. Their natural rubber is not suitable, because natural rubber will be swelled, even if it is cross linked, it will swell in contact with diesel or petrol. But if you take some, say, synthetic rubber, special rubber like say nitrile rubber or chlorophene rubber, so that is resistant to swelling in those oil. So, this is one property, and there are certain applications for high temperature sealing in oil environment, high temperature sealing. So, environment is high temperature as well as in contact with some petroleum oil, there you have to use special purpose like say silicone rubber or fluoroelastomers will be suitable there. Okay. So, this way we go for special purpose rubbers depending on the properties we need. Then general purpose and non oil resistant rubbers are, these are the examples: styrene butadiene rubber, non oil resistant polyisoprene rubber, IR, polybutadiene rubber BR, isobutadiene isoprene butyl rubber, ethylene propylene rubber EPDM, thermoplastic rubbers. These are non oil resistant rubber. That means you cannot make any product which has to perform in contact with oil, I mean petroleum oil, petroleum based oil, not vegetable oil. This is the formula of the basic formula of the styrene butadiene rubber, and this is synthesized by emulsion polymerization or solution polymerization. By emulsion polymerization, there are mostly two processes followed today. As a hot process carried out at 50 degrees Celsius, cold process carried out at around 55 to 10 degrees Celsius, and these process actually gave different microstructures of the polymers, and due to the difference in microstructure, their processing characteristics, their final vulcanized properties are dependent on the process by which they are mentioned, they are synthesized, and because of those things there are large number of grades commercially available in the market where such variations are there. So, you have to select a suitable grade for your rubber product you are going to make. Solution rubber means produced by solution polymerization technique, it gives better grades with controlled microstructure, where you can have a better control on the microstructure. Whatever you want, you can have a control, you can get that microstructure of the polymer. Special purpose rubber, chlorophene rubber, chlorosulfonated polyethylene, I have mentioned the names: acrylonitrile butadiene rubber, nitrile rubber, polyacrylic rubbers, fluorocarbon rubbers, silicone rubbers, polyurethane rubbers, ethylene acrylic rubber, ethylene vinyl acetate rubber, polysulfide rubber. So, these are all special purpose rubbers. Other than these examples, there may be many other polymers, because you know there is a versatility and tailorability characteristics of the polymers. So, you can make a design, new design of polymer, you can synthesize, you can commercially develop by developing a suitable technology, these special purpose rubbers. Properties of cold SBR, you see some properties are mentioned over here. This is cis-1,4, it contains a mixture of cis-1,4 polybutadiene. You can have means butadiene unit. The butadiene unit in the SBR will have certain percentage cis form, certain percentage trans form, certain percentage 1,2-butadiene. This is wrong, butadiene E, in place of T it will be E, 1,2-butadiene. Okay, 1,2 structure or 3,4 structure, both are same. Intrinsic viscosity, gel content, Muni viscosity. Muni viscosity, you see, what is Muni viscosity? Muni viscosity is the viscosity of a rubber compound before compounding. You can measure the Muni viscosity of raw rubbery polymer. After compounding, prior to vulcanization, you can measure the viscosity, because this viscosity can tell you at what temperature, how, at what machine speed, means RPM, revolutions per minute, you have to run the machine for getting a rubber compound in a reasonable length of time. Okay. That viscosity actually it is related to the torque developed during processing. So, it is measured through a torque measurement. How it is done? You take a small compound of a small amount of rubber. Now, there is a rotor in a cavity. that rotor is connected to a motor, okay, which is connected to transducer to measure the torque. So, that rotor can be rotated with the help of a motor, and within that cavity you place the rubber, then close it, and that cavity has arrangement of heating. So, supply heat, so the temperature is maintained at 100 degree Celsius or some other temperature of standard specification. Okay. So, at that temperature when it equilibrate after achieving equilibrium temperature of 100 degree Celsius, then you start the motor. So, it will run for 1 minute first, then after 1 minute you are running, then it will again achieve the equilibrium, then after 4 minute residence over there, you see how much is the torque. If it is 50, then it is the Mooney viscosity, the number is 50, the Mooney viscosity is called 50. If it is 60, Mooney viscosity is 60. So, at ml is 1 plus 4 100 degree Celsius, it is reported like this 50, 40, 30, 35, 45, 52 like this. The higher the number, higher the viscosity, lower the number, lower the viscosity. For gum rubber, sometimes Mooney viscosity might be say 40 to 50. For compounded rubber, where the fillers and other additives have been incorporated, but it is not vulcanized, unvulcanized rubber compound containing the fillers, that Mooney viscosity may be as high as 60, 64, 70 like that. Okay. So, that tells you how much torque is necessary, how much shear force has to be provided, has to be given in the equipment to during fabrication of the product. Say during extrusion, how, what will be the rotor speed of the extruder. Okay. So, that will be dictated by this Mooney viscosity number. Okay. So, very high means high viscosity, low means low viscosity, then specific gravity. These are the properties have been evaluated for synthetic rubbers, and that is the same properties are also evaluated prior to vulcanization, prior to compounding, etc. All these things, these properties are evaluated for natural rubber also. And these are the various grades. So, as I mentioned, various these are available in large number of grades, only few are mentioned over here in order to maintain the clarity or for your comprehension all these things. So, I have only included few grades, there may be many other grades. Say within say 1500 category, say there may be 1502, 1505, 1503, 1507 like this. So, those are those are different grades having difference minor not major, but minor difference in properties there within the internal grades. Styrene butadiene rubber applications, tires, footwear, mechanical goods, sponge, foamed items, waterproofing items, hose, belting, adhesives, carpet backing coatings, sometimes sealants, sometimes your rubber coated fabrics, all these many. So, that means the large number of products can be fabricated from synthetic rubbers as well as from natural rubber. Now, come to the details of the ingredients. Look at the filler. There are two categories of filler, reinforcing fillers and non-reinforcing fillers. Reinforcing fillers, that improves the strength properties of the rubber compound by their presence. That means, they enter into a direct interaction between the polymer and the filler. So, there will be, if there is some interaction between the polymer and the filler, then we call it is a reinforcing filler. For example, carbon black. The structure of carbon black, structure means physical structure, morphology of carbon black. This say if you consider a spherical particle of carbon black, the spherical particle of carbon black can be considered as a quasi crystalline graphitic layer planes of carbons. Okay. And there is spacing between two layers, and it is very light and floppy. That means, there is ample free volume within a carbon black particle, even if it is very small in diameter, say 10 nanometer or 30 nanometer or 50 nanometer or 100 nanometer or 300 nanometer like that. So, there are these free volumes or voids in carbon particle, and they are quasi crystalline graphitic planes. Now, each such type of or sphere can be considered as a nodule. Now, again there are internodular fusion in a carbon black particle. That means, one carbon black particle is not an isolated spherical carbon black particle. No, there are nodular fusion structure, fusion morphology, fused nodular structure. That means, there may be many more such nodules fused one with the other. So, one nodule may be considered like this, layers are there inside, layers are there, fine layers are there like this. So, this is these are fused together. So, here is the fusion, 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 here is the fusion. So, this entire fusion, fused nodular structure is known as structure of carbon black. There are high structure carbon black and low structure carbon black. High structure means higher extent of nodular fusion, low structure means lower nodular lower extent of nodular fusion. Now, again they dictate the processing characteristics of a rubber compound, while carbon black is used as a filler for incorporation and dispersion. Now, it is known, it has been found, it has been verified, experimental probed that high structure carbon black is difficult to incorporate in rubber compound, but it is easy to disperse. Please note it down. High structure carbon black is difficult to incorporate in rubber compound, but it is easy to disperse. Once it is incorporated with difficulty, then the latter part of dispersion becomes easy. High structure means this, if this structure is high or longer, then by virtue of their bigger volume it is difficult to incorporate in rubber, but they are easy to disperse, because the carbon blacks has a property of agglomeration by virtue of their surface forces, surface energy. Okay. Even if you incorporate in rubber, so they will try to form aggregates or agglomerates. Now, in order to get a better dispersion, that means you have to separate all these things, so that it is well dispersed in the rubber matrix, and that means each and every small particle should be covered by rubber. Otherwise, there will be, if there is some aggregate, that aggregate is made of carbon, there is no polymer, then that is the weak side in the rubber product, and the stress will be concentrated in that weak side, and the tire or the rubber product will fail at dynamic stressing, dynamic loading. Okay. So, this is the problem. So, in order to avoid those problems, overcome those problems, what we need? We have to properly disperse this carbon particle within the rubber. So, here the problem comes, high structure carbon black particles are difficult to incorporate, but easy to disperse, because they are not prone to form aggregates, because they are of your bigger particle size, bigger your nodular structure. So, they are difficult to incorporate, but easy to disperse. On the contrary, if you take fine structure, low structure carbon black, they are easy to disperse. Those rubber, your carbon black particles, low structure carbon black particles can be easily accommodated, but once it is accommodated, immediately they will form aggregates, and then the breaking of those aggregates is rather difficult. Why? Once they form aggregate by virtue of their surface forces, surface energy, then if you want to break those aggregates, you have to go for extended milling in the mill. That means, you have to apply prolonged shear force in the rubber compounding machine. So, that will again decrease the molecular weight of the product, rubber molecules, molecular size of the molecules. If the size of the molecules are shortened that way, then the final mechanical properties of the ultimate mechanical properties of the final product, vulcanized product, will be inferior. So, these are problem. So, it is so you have to take care of all this. So, for those things we have to use some processing aids, because during such application of shear force, it will continuously go on increasing the temperature, mechanical energy will be converted to thermal energy. So, that will increase the temperature of the rubber compound, and that will cause adverse effects on the rubber product. So, that is why one has to have some control and compromise during compounding with these things. So, this is carbon black, and by virtue of that floppy structure, by virtue of those free volumes, these ends of the rubber molecules and the segments of the rubber molecules get occluded within the porous structure. You see here is some free volume, free space. Now, a part of the rubber molecular chain, say some segment, can be occluded over there, can be entangled over there. Not only that, ends of polymer chain can be anchored over there. So, this kind of anchorage through occlusion of part of the segments or ends of the polymer chains will occur in our carbon black particle, and here is the mechanism of reinforcement. This is in brief the mechanism of how reinforcing occurs, because if you have seen there is some you see wild fruits with thorny surface, you have seen in the childhood days, probably you have played with those things, just you are throwing on the hair of your friend. So, it sticks to it on the head, on the hair, thorny surface, it is like that. That means, if you put a carbon black in rubber, what will happen? The ends of polymer chain occluded rubber goes inside and it gets anchored, and then after that, once it is anchored, it is difficult to separate from there. Okay. So, this is the phenomena, occlusion and anchorage, and this gives physical anchorage. So, physical entrapment of rubber molecules with the polymer your carbon particle, and that is called this way it helps in reinforcement. Other than this, there is some chemical interaction between carbon black and rubber chain, okay. That also adds to reinforcement properties, reinforcement characteristics. So, reinforcement occurs in two ways, physical anchorage and chemical interaction. So, in general we can say there is physico-chemical interaction between carbon black physico-chemical interaction between carbon black and rubber molecule is known as reinforcement. This is a brief idea of reinforcing by a filler particle in rubber. There are plenty of literature available on this thing, okay, that needs say a few hours to cover all these things, only reinforcement mechanism. I know all these things, but we do not have scope to discuss those in detail in this class. Non-reinforcing fillers, these non-reinforcing fillers, they remain present within the rubber compound as simple filler just to increase the volume, thereby reducing the cost of the product and sacrificing some mechanical properties, okay, that is called inert fillers. And the examples are here, you see calcium carbonate, titanium dioxide, various clays, different grades of clays are available in the market, commercial clays, China clays, soft clays, hard clays, calcined clays, graphite, magnesium carbonate, talc, French chalk. So, these are used as inert fillers, and it is good for their dispersion if they are actually modified with some organic material, then it becomes easy for the incorporation and dispersion in a rubber compound. Processing aids, peptizers, these peptizers you see while going to incorporate these particular additives in rubbers, we need to decrease the viscosity of the raw polymer. Say for example, if the Muni viscosity of the raw polymer is 50 ml 1 plus 4 100 degree Celsius is 50, then you cannot incorporate any of these particulate additives. So, you have to bring down this Muni viscosity from 50 to 35 or 40. For doing so, then you have to apply some mechanical shear force. By mechanical shear force, it will decrease the molecular weight by breakdown of the molecules, that is known as mastication. Mastication process breakdown of molecular length of rubber chain. Say suppose this is the length of a rubber chain, mastication. So, it will form two part after breakdown by tearing, a simple tearing by shear force here. So, two free radicals are generated. Now, this is a reversible process. They can recombine again, mastication and recombination. Recombination, they can recombine again. Okay. If it is recombined, then our purpose is not served, that is mastication has not affected. So, it needs more time of milling, more milling time. As you go for more milling time, then you are losing power, that means you are costing more, you are increasing the price of the product. So, that is not advisable. So, what we need in order to prevent such type of recombination, that means in order to avoid this process, the reversible process, reverse path, what do you do? We use peptizer. Peptizers are radical scavenger, free radical scavenger, radical scavenger. What it does? Say if there is a free radical scavenger, so peptizer, let me say show you the first peptizer. Suppose RSH is a peptizer, a thiol type or disulfide type. Okay. So, what they do actually, they thermally break down forming RS radical plus H radical, or it can form 2 RS radical. Okay. Means this kind of radicals, these are either RS radical, no, this is not like this. So, these are from the this disulfide or peptizer molecules. Then what happens? This free radical, rubber free radical which has been produced, when it comes in contact with this broken peptizer radical, so it scavenges this thing, forming this bond. So, by this way it prevents the recombination reaction, this reverse process, it prevents the reverse process. So, peptidation occurs. So, when actually in real compounding phenomena, what happens? In an internal mixture, if you use peptizer, this mastication step can be completed within 3 minutes, whereas if you do not use peptizer, it may linger up to 5 to 6 minutes, okay, in one batch. So, 3 to say the additional 3 minutes or 4 minutes times, and running of such a huge machine with a huge motor, you can understand what is the amount of power required for running for that period, that length of time. So, a rubber mill may be as wide as the breadth of this room, and height may be bigger than the height of this room, your beyond ceiling. For rotating, and rotors are very big there, for rotating such rotors using high viscosity polymer over there, you can understand how much is the power consumption. So, saving that power consumption for 3-4 minutes in one batch is a very big thing, saving lot of price. Okay. So, for that purpose these peptizers are used. Here you see the chemical compounds: diorthobenzamidophenyl disulfide, activated diorthobenzamidophenyl disulfide, or zinc sulfate of pentachlorothiophenol, with activating and dispersing additives, metal complex on an organic carrier. Okay. These are actually used as peptizer molecules, these are commercially available in the market. Then processing aids, petroleum aids, ester plasticizers, petroleum jelly, paraffin wax, glycols, fatty acids and salts, factice, pine tar, bitumen ester, all these things, and phthalate ester plasticizers, dioctyl phthalate, dibutyl phthalate, diisooctyl phthalate, DIOP, all these things you have seen in case of plastic products. Okay. These are not new. Cross-linking vulcanizing agents, as I mentioned, sulfur and related elements, sulfur bearing chemicals, non-sulfur cross-linking agents, these are vulcanizing agents used for making rubber products. Then accelerators. Now, there are various accelerators available in the market, which are really used in commercial practice. Say mostly the sulfinamide categories, thiazole category, sulfinamide category, dithiocarbamate category. That means, starting from here, thiazole, sulfinamides, dithiocarbamates, thyrone sulfides, xanthates, thiocarbon sulfides, these are mostly used in making rubber products. Now, actually as you pass from top to bottom, the speed of their acceleration or reaction increases from top to bottom. That means, these are all faster reacting gradually after this. Now, if I show you some formulas, you see, say MBT. What is MBT? This is the MBT. I am sorry, here it will be sulfur, sulfur, this is sulfur, okay. SH, this is 2 mercaptobenzothiazole, mercaptobenzothiazole known as MBT. Similarly, its disulfide is also available. Two mercaptobenzothiazyl disulfide MBTS. Okay. Similarly, its zinc salt can be available, where zinc will come in between these two sulfur, zinc salt. Okay. Sulfinamides say CBS. This is N-cyclohexyl 2 mercapto benzothiazole, thioazole, benzothiazole sulfinamide. Okay. And dithiocarbamate, I am just showing you, say ZDEC, zinc diethyl dithiocarbamate, zinc diethyl dithiocarbamate. Okay. Say I am writing this structure formula, Et nitrogen, Et ethyl groups, this is ZDC or ZDC. Okay. Acha. Then next category is TMTD, thiourea disulfides, thiourea sulfides, say tetramethyl thiourea disulfide. Okay. Then another is tetraethyl, just in place of methyl group, if you write ethyl here in place of methyl, it will be TETD. Then xanthates are actually again same type of formula, but they are xanthate accelerator. xanthate accelerator. Xanthate, xanthate, this one, xanthate. Actually, this is wrong, it should be thio, not thiso. S should be dropped over here, this is wrong here. Thiocarbamyl sulfonamide. If you have a doubt, you can discuss with me after this class. Okay. Thiocarbamyl sulfonamide. What is this thiocarbamyl sulfonamide? Please look. This is a thiocarbamyl sulfonamide. This is actually thiocarbamyl bond. Sulfonamide, thiocarbamyl, thiocarbamyl. Salt of thiocarbamic acid. If you do not know the chemistry, it is difficult for you to understand. So, I am not going to that depth. Okay. So, this is thiocarbamyl sulfonamide, and you can have other thiocarbamyl sulfonamide like CH3, say you can take morpholine, sorry CS, this is S N again morpholine. This is actually OTOS, chloride 18 OTOS. Oxy diethylene, the oxy diethylene thiocarbamyl, N single bond C, double bond S, single bond S, N again diethylene thiocarbamyl sulfonamide. It is actually called oxy, the name is is a Monsanto chemical product. In the trade name chloride 18. Thank you very much.